Okay, Algebra 2 skills number 38, compound interest. Compound interest is a special case of an exponential growth. So you can see here where we are adding, and it looks a lot like that exponential growth model, but there's a little bit more to it. So these variables, P is your principal, which is your current or original amount. Just like in the exponential model, we had our original amount up front. This again is number one. It just holds that P value, and we're adding interest to it, so that we expect it to grow. N is a number of compoundings per year. We'll have a special slide for that in just a minute. R is your rate, just like before, and T is time. So let's look specifically at N. You're going to see different words associated. They're LY words or adverbs. If you see the word monthly, that's going to be 12, because there's 12 months in a year. Quarterly, there's 4 quarters in a year, like there's 4 quarters in anything. Semi-annually, there's two of those, so semi means half. And then annually, you'd have 1. That just means once per year. So example 1, so you can see here, how much money will an investor have if he deposits $20,000 into an account that draws 6.5% interest, compounded quarterly over 10 years. So let's write the formula. And then we're going to fill the values in. So notice I put $20,000 in the principal position. 0.065 is your rate. Remember, that's not 6.5. That's 6.5%, which means 6.5 divided by 100. Move your decimal 2 positions to the left. Quarterly means 4. So you have 2 4s and then 10 years. And you just simply type that in. So I just did it all at once. Now this is money, so in context we should round to the nearest cent. We shouldn't have a bunch of decimals through here, nor should we round to the nearest whole dollar, because banks are going to get you to the penny. Also notice this answer makes sense. You expect to make money, but you don't expect to make a ton of money. I mean, you're not going to go from 20,000 to something in the millions over the course of a few years. Second example, how much money will a woman have if she deposits $15.50 into an account that draws 2% interest compounded monthly? All right, very similar. We start with $15.50, we're compounded monthly, so now N is 12, 2% right here, and then 4 years. And again, this not being a very high interest rate and not being a lot of time, you're not going to make much, but you did go up some. Third example is a little harder. So here it says Jeff wants to have $10,000 in his account, and he knows the interest rate, 2.8%. He knows the compounded frequency, semi-annually. How much should he put into his account? So here, we actually don't know the principal. We know how much he wants to end up with. So what we've got to do is put this part into our calculator. So again, 2.8%. Semi-annually is why we have 2, and it's 5 years. So if you figure this out, now I wrote 1.149. It's really more than that. And when you're working these problems, you want to make sure to get as many decimals as you can, or leave the whole answer on your screen, because if you round off too much with large numbers, it really compounds that error, so be careful. And when we divide, this is a number that makes sense. We know it's going to be less than 10,000, right? Because he wants to get up to 10,000, so this is a number that would make sense there. Compound interest.